Hello and welcome to a video about elastic collisions. This GIF is from The Amazing Race, I think in 2010. They had to do a challenge where they slingshotted watermelons somewhere. Unfortunately for this person here, it didn't work out so smoothly. I'm not sure if this GIF is going to show up that well in the recording. If it doesn't, just look up Amazing Race watermelons. Anyway, I thought it might be slightly relevant. So, an elastic collision is one in which the total initial kinetic energy equals the total final kinetic energy. In an inelastic collision, some kinetic energy is transformed. In Stage 2 physics, you're expected to be able to describe the difference between an elastic collision and an inelastic collision using examples. You also need to be able to solve problems involving one-dimensional collisions using the kinetic energy equation, Ek equals half mv squared, and the equation for momentum, which is P equals mass times velocity, or momentum equals mass times velocity. You also need to be able to describe the energy transformations during inelastic collisions and undertake experiments to investigate the conservation of energy or the conservation of momentum. So, just to reiterate, I suppose, an elastic collision is one in which kinetic energy is conserved such that the total kinetic energy before the collision is equal to the total energy after a collision. So a shorthand way of writing this is that kinetic energy is conserved in a collision. The total energy before, or the total kinetic energy before, is going to equal the total energy after. If the collision is inelastic, a quantity of energy is transformed and therefore the kinetic energy is not conserved. The total kinetic energy of the system before the interaction is going to be greater or more than the total kinetic energy after the collision. So, shorthand way, kinetic energy is not conserved in a collision, it's transferred into another form of kinetic energy. Oh, that's a terrible line, I'm going to do that again. It's transferred into another energy form, so therefore the total kinetic energy before the collision is going to be greater than the total kinetic energy after. So, two gliders collide on a frictionless air track. Glider A has a mass of 370 grams and a velocity of 4.2 meters per second to the right. Glider B has a mass of 350 grams and a velocity of 2.8 meters per second to the left. Calculate the total momentum of the gliders before the collision. So, to do this, we'll just use our momentum equations, which we have been using previously. So, total momentum equals momentum of A plus the momentum of B. This is going to be equal to the mass times velocity of A, the mass of A by the velocity of A, plus the mass of B by the velocity of B, and this is initially. The mass of A is 370 grams, so 0.37 kilos. The velocity is 4.2 meters per second. Mass of B is 350 grams or 0.35 kilos, and the velocity is 2.8, but it's 2.8 to the left, so I'm going to say that left is negative in this situation and right is positive, so it'll be minus 2.8. If you pop all of that in your calculator, you'll end up with a momentum of 0.57 kilogram meters per second. It's like a motorbike or something tearing around. I'm not sure if you can hear that or not, but sorry if you could. So to work this out, we use our equation. Momentum total equals momentum of A final plus the momentum of B final. The momentum is always conserved regardless of whether or not energy is conserved. So our total momentum from the previous slide is going to be equal to the total momentum on this. So the initial momentum will be equal to the final momentum. We're looking for the final momentum of B, so we'll just rearrange this one to say the final momentum of B is equal to the total momentum minus the final momentum of A. If we sub in our knowns, total momentum is 0.57. The momentum of A is going to be equal to I'm going to write this up here, total momentum minus mass of A times the final velocity of A, and that is going to be 0.35 and then minus 2.6, which is our final velocity for A here. It's to the left, so it's going to be minus. If you pop all of that into your calculator, the final momentum for glider B is 1.5 kilogram meters per second. And because it's a positive number, it means that it's going to be to the right. The next question wants us to calculate the final velocity of glider B. So to do that, the final momentum of B is equal to the mass of B by the final velocity of B. This rearranges to the velocity of B is equal to the final velocity of B is equal to the final momentum of B divided by the mass of B, which is equal to 1.5 kilogram meters per second, so that's the final momentum of B, divided by 0.35, which is the mass of B, and that is equal to 4.29 meters per second to the right because it's positive. Obviously the momentum is to the right as well, so the velocity is going to be in the same direction. I've just realised I've used 3.5 up here instead of 3.7. The mass of glider A was 370 grams, so apologies for that. It's still 1.5 kilogram meters per second to the right because I've worked it out correctly in my notes, but I just copied the wrong mass. Sorry about that. The next question is asking us to determine the total kinetic energy of the gliders before the collision. So to do this, we'll need to add the kinetic energy of A, or the initial kinetic energy of A, and the initial kinetic energy of B. So this will be half mass of A initial velocity of A squared plus half mass of B initial velocity of B squared. This will be 0.37, got it correct this time, and the initial velocity of A was 4.2 meters per second to the right, 4.2 meters per second to the right. And the mass of B, or half, and then the mass of B, which is 0.35, and the initial velocity of B was negative 2.8, and then squared. Because we're squaring that term, the negative is going to disappear, but it's good practice to write negative just in case. If you pop all of this into your calculator, you'll end up with 4.6 joules. So that's the total kinetic energy of the system, or the glider A plus glider B. Next question wants us to determine the total kinetic energy of the gliders after the collision and hence state whether the collision is elastic or inelastic. So to do this, it's the exact same process. We're just looking at the final kinetic energy, or the final total kinetic energy. So this will be the final kinetic energy of A plus the final kinetic energy of B. So this will be half mass A velocity of A final plus half mb velocity of B final. Sorry, those velocities should be squared. So mass of A 0.37, final velocity of A is negative 2.6 meters to the 2.6 meters to the left, so negative, and then squared plus half mass of B, which is 0.35, and then the velocity, final velocity of B, which was 4.29 to the right, so it's positive, and then that's squared. So if you pop all of this into your calculator, you'll end up with 4.5 joules. So because the total kinetic energy of the collision or post collision is 4.5 joules, whereas the total kinetic energy of the gliders or the system before the collision is 4.6. The collision must be inelastic because those three dots here mean because. I could hardly call them dots, but whatevs. The total kinetic energy to begin with is greater than the total kinetic energy after the collision.